Hi everyone, I just wanted to remind us that we kind of left off with our lecture on amino acids. We were kind of going through these different side chains. And just to reiterate some points that we made before, remember that the N, that C alpha, and then the C double bond O, that carboxylate group, these atoms in here are the main chain, and those are constant for every amino acid. So if you notice, all of them have those same groups of atoms on the right-hand side. And as we've drawn these this particular way, then the side chains are all going off to the left. So the variable part is known as the side chain. And I won't have you memorize these structures. You're not going to have to draw them. I'll give you the structures and the codes, but you'll have to associate the structures with the names. That will be your task. And so we were going through these, and I just pointed out a few important concepts like the term aromatic, and then we talked about how things can form other interactions like hydrogen bonding interactions, introduced the idea of a phenol functional group. And as I want you to add the word amide, A-M-I-D-E, to looking when we look at this side chain on asparagine and glutamine, we're going to see here in a little bit that is actually a new functional group that we're going to learn here. Another one that we're going to learn is called imidazole, so histidine. This amino acid here has this nitrogen-containing 5-membered ring, and that is called an imidazole. And as we said, that can sometimes be positively charged. And then we left off on this page talking about the polar charged amino acids and how the aspartic acid or aspartate, glutamic acid or glutamate contain a carboxylate side chain. And the pKa's of those are about 4 or so, again, within that expected 2 to 5 range. And then that left us with the two last ones we looked at, lysine and arginine. These are nitrogen-containing amine side chains then that are going to be positively charged at physiological pH. And this arginine is pretty much always going to be positively charged, has a very high pKa. Lysine is kind of on the edge, or a little bit over the edge of our range. It's up about 10.5, but again, I don't need you to memorize those exact pKa values, but it should make sense, this being a protonated amine, that it's going to have a pKa somewhere around 10 or so. Speaking of those charges, I want us to take a minute and think about the charges on an entire amino acid, both the main chain groups and also then the side chain groups, and what the overall charge will be for an amino acid. So again, same thing we've been doing. Think about the pKa of a functional group and then the pH of the environment. So here we're going to look at the charges of glutamate at pH 7. So I'm going to draw glutamate out, and this is the way it would appear at 7. I'm going to draw it in a kind of like what they are in the notes there. So I have the side chain over here on the left, the carboxylate group. I'm going to draw it negatively charged since it is again, we're at pH 7, so physiological pH. And then I'll draw the amine going down, and then I'll draw the carboxyl group going to the right here. And just to be clear what these things are, this is the main chain carboxyl group. And the pKa, right, we call that pKa 1, which is about, in the sort of 2 to 5 range. That pKa is somewhere in the 2 to 5 range. And so this is going to be -1 at pH 7, right? Because the charge here will be negative because we're going to remove that proton, because the pKa of that group is 2 to 5, and we're then the pH is greater than that, right? And then similarly, we can look at the main chain amine here. Similar analysis, right? The main chain amine is going to have a pKa somewhere in the 8 to 10 range, and so it's going to be +1 at pH 7 because, again, the pH is lower than the pKa in that case, so the opposite as it was with the carboxyl group. And similarly, on the left here, this is the side chain carboxyl group. And this one, again, pKa, we kind of know that it's more like 4, but again, we can use our estimate of about 2 to 5, and so that means it's going to be -1 at pH 7. And so if you kind of sum all these up and look around, you can say, hey, look, this is often the case that at pH 7, that the amine and the main chain carboxyl are going to cancel each other out, and then whatever the charge of the side chain, in this case, will dictate what the overall charge is. So we can say that overall charge here is -1, right? So you can, -2 plus 1 gives you a -1. So let's do another example on the next page. This is the charges of lysine now at pH 1. So we're dropping the pH quite low down to the acidic range. And so I'll draw out the structure of lysine that I expect. Again, it's going to, pH 1, pretty much everything that can be protonated will be protonated. That includes the side chain. And the main chain amine, both of those will be protonated. And then also the carboxyl group will be the carboxylic acid form. It will then be the neutral form. So just again, same idea right here. The pH of the solution is now less than, we can call this either, that we remember from our notes earlier, this is called pKa1. It's the main chain carboxyl group. And then here, the pH is still less than pKa2, certainly, being up around 8 to 10. And so the last thing to consider then is the side chain here, right? pH, in this case, is definitely lower than that pKaR, the side chain pKa. And so it should make sense that at pH 1, all the groups that can be protonated will be protonated. And so that's why in this example now we have the overall charge equals a +2 now, because we don't have a negative charge from the carboxyl group, and then both amines are giving us then that positive charge.